Right, this is video 2.7 for Algebra 2. Today we're going to be talking about linear regression, which is just when you have a linear model that doesn't make a perfect straight line. It is a best fit line that will describe the data that you have. Vocabulary for this, so regression is just going to be, it's a statistical study. It's something that's related to statistics, and it studies the relationship between variables. So maybe you're talking about distance and time, or you're talking about the rise and fall of the stock market, or anything like that is going to be where there is a relationship between two variables. Regression is the study of that relationship. Now, how well the two variables relate to one another in a linear relationship is going to be called their correlation. So think of the relationship and correlation as how they fit together. So if one goes up and the other goes up, we would say that there's a positive correlation. If one goes down and the other goes down, then we would say they have a negative correlation. If one goes up and the other goes down. So how they're related and how strongly they're related is going to be their correlation. So a best fit line is if you have a strong linear relationship, there's a strong correlation, you can make a line that's going to go through the data, and then that best fit line, it's not going to be a perfect line, but the best fit line can be used to make predictions for the future. So the number that tells you how strong that relationship is called the correlation coefficient. We call it an R, and so it is going to be between a 0 and a 1. A decimal there. So the closer you are to 1, the stronger the correlation is, and then the weaker the correlation is going to be closer to a 0. So this here is an example of a positive correlation. One goes up, the other goes up. There's a positive slope. So if we were to draw a best fit line, it might look something like this. You see that it doesn't go through all the points, but it goes through some of them and kind of follows the general idea of the way the data would be plotted. A negative correlation is going to be where when y goes up, x goes down. And then if you have one where there's no correlation at all, they don't make a line at all, then you would say that there is relatively no correlation. So your R, your correlation coefficient, is going to be really small in this one. The R coefficient is going to be pretty good in this one, and only so-so in that one, and that won't exist at all in that one. All right, let's try this out. We have some data here from temperatures of Akron, Ohio and Wellington, New Zealand. And they are about the same distance from the equator. We want to see if there's a correlation between their temperatures. So the first thing I'm going to do is I'm going to graph them out. Now, this is going to be my x. Always make your top one be your x and your bottom one be your y. So Akron goes down here on the bottom, and Wellington is going to go over here on the side. Now, Akron, its smallest is at a 33, and its largest is at a 82. So I'm going to start it at 30 and go by increments of 10. For when I plot my data. And then Wellington starts at a 51 and only goes up to 67. So I don't have to go quite as far. So I'm going to do 50, 60, 70. Now I'm just going to go through and I'm going to plot them. This is my x and this is my y. So I'm going to go to about 33 and then go up to 67. Then I'll go to 37 and go to about 67. 48 to 56. Be about right there. 59 to 61. About right there. 70 to 56. 78 to 53. 82 to 51, 80 to 52, 73 to 55, 61 to 57, 49 to 60, and 38 to 64. So that's our scatter plot. Now we can identify our correlation. We can see that the line kind of goes in a negative fashion. So remember, this would be a positive correlation and this would be a negative. So we would say that the correlation here is negative. So now we're going to sketch our best fit line. Remember, it's not going to be perfect. We want to hit as many dots as we can. It's a sketch of a scatter plot, so it's not that great of a graph to do your best fit line through, but you're just going to draw as straight a line as you can, hitting as many points as you can. From there, that's going to be our best fit line. We need to find the equation. So to find the equation, we need a slope, and we need at least 1 point. So these 2 points right here kind of go through it. Those look like good points that we could use. I believe that is the 6157 and the 7056 maybe. So I'm going to find my change in y's and my change in x's. So my 57 minus 56 is going to give me a 1. And 61 minus 70 will give me a negative 9. Let's go ahead and put it as a decimal, which is going to give me negative 0.1. So that's what I'm going to use as my slope. So I'm going to take my 2 points. Just going to pick one. I'll pick this one. Y minus 56 equals negative 0.1 x minus 70. So that'd be y minus 56 equals negative 0.1 x plus 7. Move my 56 over. I'll have y equals negative 0.1 x plus 63. Now, depending on if you're doing it by hand, everybody's probably going to come up with a different equation for the line, especially if you're doing it like the graph we have here where it's not exactly perfect. So the better way to do it is to be using your calculator, which I'll show you on your next example. So anthropologists will use the relationship between a person's height and how long their humerus bone is, which is the bone between your elbow and your shoulder. And so that relationship, if they have just the bone, they can estimate how tall a person is. So in this case, we're talking about women's heights. And so we have some samples shown in the table. So go ahead, I need you to copy down the samples, the data, because I'm going to need to switch the slide over to show you how to do it on the calculator, and you'll need to be able to come back to that data. All right, so on your own, actually, you can scatter plot the data. Remember, this is going to be your x and this is going to be your y. So we would have the humerus and then the height over here. So my height, my lowest one's a 140, and my humerus starts at about a 25. So a good place to start here on this graph would be a 20, 30, 40. And over here we can start at 140, 150, 160. So 35, 167 is going to be there. And then 27, 146 is going to be there. 30, 154 is about here. 33, 165 is about there. 25, 140 here. 39, 180 up there. 27, 149 and 31, 155. So we could say by looking at this, there's a positive correlation going through about right there. So what I'm going to show you is how to find the correlation coefficient and the equation for the best fit line. Okay, so you could draw it on your own, but let's find the equation for it. We're going to do that using the calculator. All right, so on your calculator, this should be what it looks like. What you're first going to do is we're going to enter our data into lists 1 and 2 on the calculator. Okay, so to do your data, you're going to hit. Okay, so the first thing you're going to do is we're going to go to the list. So we're going to click Stat. And then you're going to get a list up there. So it's going to, if you do stat, it'll say 1 edit, 2 sort A, 3 sort D, and 4 clear list. What we want is edit. So you're going to do stat and then edit. And you should have 3 or 4 columns that pop up. They say L1, L2, L3. If you have numbers in your column, if you'll just highlight them and clear them out, so you can highlight them and hit delete, or you can hit clear until all the numbers are gone. You shouldn't have any numbers in your lists at all. So if you'll scroll over to, so that L1 has kind of highlighted like this, we are going to put our humorous data into L1. So if you'll hit 35, enter, 27, enter, 30, enter, 33, enter, 25, enter, 39, enter, 27, enter, and then 31, enter. And then use your little arrows to scroll over to list 2. In list 2, we're going to put our height. We're going to put 167, and then 146, 154, 165, 140, 180, 149, and 155. So that's your list. All right. The next thing you're going to push. Okay, so now you're going to go back and you're going to click the stat button again. And then this time you need to arrow over to the word calc. Underneath that menu, the first one is 1 variable stats, 2 variable stats, 3 is setup, 4 is, mine says med. You want number 5, which is len reg ax plus b. You want 5. Your calculator, some of you, it may be on number 4. It kind of depends. So the calculator I'm looking at right here at home is a TI-82, so it's a little different. So pick the one that says len reg, which is linear regression. What pops up might be where it says, this is what your screen might look like, len reg ax plus b. We have to tell it what list we want in there. So what you'll do then is you want to do second, and then 1, and then a comma, and then second 2. So what this tells it is that you want to use list 1 as your x and list 2 as your y. So then you'll hit enter after you do that. So list 1, comma, list 2, enter, and you should get a sign that says len reg y equals ax plus b, where a is equal to 2.75 is what mine says, and b equals 71.97. And then mine says r is 0.99. Okay, so a 0.99 is a really good correlation coefficient. So that if we were writing the equation, we would say y is equal to 2.75 x, sorry, not parentheses, 2.75 x plus 71.97. And we could take this equation and we could use it to forecast how tall someone should be if we knew how long their humerus was, or if we knew how tall someone was, we could find out how long their humerus is. Let's try it with another one. So on this one, I'm going to show you how to graph the line as well. Okay. So go back to your stats, and then you'll go to edit, which is number 1. You're going to need to clear your list out. List 1 is you're gonna put in your fat. List 2, you'll put in your calories. So this will be a 5, 9, 12, 15. Go ahead and put your 12 in again because it's gonna have a different plot right there. 10, 21, and then 14. Under list 2, make sure they're lining up. 360, 455, 460, 420, 530, 375, 580, and 390. All right, once you have your lists in, remember you go back to stat again, arrow over to calc, pick your len regress, ax plus b. You'll need to put in your len regret, L1, comma, L2. So all of that is the same as what we had before. Your new step, in order to see what your graph looks like, is you want to go to, you're going to press your y equals button up there in the top corner. And then after you press that, you're going to press vars. So I'm going to go to the next slide so that you can see on the calculator. So after you have your list all done, you're going to do y equals and then vars. That's the variables. So you'll scroll down and choose the one that says statistics. And then from statistics, you're going to go right until you get to eq, which is equations. And then you want to select the one that says regression equation. They will use the one that goes with the one you just did for the calories for the nutrition. And it will put it in y equals. And then all you have to do is hit graph. And it should show up. Now, if it doesn't show up, first thing you should go to is second stat plot. We'll do all this again when we get to class because sometimes it helps to do it all together. Stat plot. Make sure that your plots are on. It's the first thing that you may need to fix. Second thing you may need to fix is your window size. So if that still doesn't work and it doesn't graph, go to window. Change your x min to 0 and your x max, change it to 30. Change your y min to 300 and your y max to 600. And then hit graph and it should show up. If it's still not showing up after you've done both of these, we'll talk about it when you get to class. Right, so this is linear regression, and that's all I have for today. Have a good evening. I'll see you later.